of solving with fractions, and it's the last video was getting quite long, so I thought I'd separate this off into a separate little task. So there's this quite relatively short video for me, I think. Well, it's supposed to be, probably won't be, but here we go. Right, we've got two fractions here. This is the third type that we were looking at in the first video that we didn't go around to talking about. And so each part of the, one side of the equation has got two separate fractions. So we need to add these two fractions together. And we are going to do it in a very similar method to how we would usually do it if there was no letter there at all. And if I had no letter there at all and I wanted to add those fractions together, what I first of all need to do is change the fractions so they had the same denominator. And I'd first of all check to see if one will go into the other, which it will. And so if I times the bottom and the top of this fraction by 2, so it's now 2/6, it will then match the denominator from the second fraction. And then it's nice and easy to add them, because 2/6 and 1/6, you add those together to get 3/6. Okay, that's but the basis of what we're going to do here. We're going to make sure that we've got denominators that match so we can add them together. Okay, well, I've just kind of given us a hint for this first one, haven't I? I can see that this first fraction, this denominator, can become 6, become the other one, and match it by being doubled. So I can do that to the top and bottom of my fraction to get two equivalent fractions. So I've now got 2a over 6 plus 1/6. Okay, right, and so because I've done that, I can now add those two fractions together. And so 2a over 6 and 1/6 together would be 2a plus 1. You can literally just write them added together like that. There's an add in the middle, so that's all I've done. And now it's all over the same fraction, just like we would do ordinarily. But of course, this is part of an equation, isn't it? So then I have to go further to solve the equation. And usually we'll then end up with the first type we had, where the whole thing is over a fraction line. And so I can deal with this here. Now, do you remember how I got rid of this? How we turned it into a straight line instead of a fraction? Yay! I don't want that divide by 6, so I times by 6. And those two things cancel out. Timesing this side by 6 cancels out the divide by 6. But I must do it to both sides of my equation to keep it balanced. So my equation is now 2a plus 1, because the fraction has gone. It's been cancelled out. But this side is now also 6 times bigger, so it's 30. And then we've got our straightforward two-step equation. We're getting great at these. Deal with the number touching the letter last. It's like a catchphrase I've got from a game show. So we'll deal with that plus 1, and we'll do it by taking away 1. That will cancel out the 1, leaving 2a all by itself. And then 30 take away 1 is 29. How do I go from being 2a? I don't want the value of 2 of them. I only want the value of 1 of them. So I'm going to halve it. I'm going to divide by that number touching the letter. And half of 29 is 14.5. Okay, second one then. So we've got two fractions here. We've got x's on top of both. That's not a problem. Now, neither of these will go into each other, will they? So I'm going to use another method here, which might need simplification later, but it's the method I would use for adding fractions that had very clearly different denominators. And it starts off by multiplying the bottom denominators together, and you get 6 if you do that. So my new denominators are going to be both 6. And then we do that cross multiplication, because 2 was times by 3 to get to 6. So I'm also going to times all of this top of this fraction by the 3 as well. Now 3 times x makes 3x. And the whole of this top of fraction could also be times by its diagonal partner, by the 2, because 3 times 2 makes 6, so we've got to times the x by 2 as well. But you can remember it like this. Multiply the two bottom ones together to get the new denominator, and then diagonally multiply to get the new tops of the fractions. All of that equals 10. Now I've run out of space at the bottom here, so I'm going to add the fractions just over here. Let's put a little wiggly line in. Wiggly, wiggly, wiggly. to separate the top fraction. Right, okay, so we're going to add these together. I've got 3x over 6 and 2x over 6. Add them together to get 3x plus 2x, which is 5x over 6. We can actually put those straight together. I don't need to leave the plus sign. I can actually add them. And that equals 10. How do I get rid of my fraction here? Oh, I do the opposite, don't I? Times by 6. And that will cancel out the fraction. But what you do to one side, you must do to the other. So 5x equals 10 times 6 is 60. And then I don't want to know the value of 5x. I only want to know the value of one of them. So divide by that number touching the x. This is all stuff we've done before. 60 divided by 5 is 12. Oh, computer's going all laggy again. That's really annoying. Right. I want you to pause the video, have a go at these two, and then we'll unpause and we'll see if you've got them right. So pause now. We have unpaused. Right, this first fraction, we can see that the 5 can become 10 if I double it. So that'd be a straightforward way to work, wouldn't it? So I'm going to double the top and the bottom of this fraction to get an equivalent fraction. Now the top times by 2, instead of 2x, it will now be 4x. It's been doubled. And 5 times by 2 is 10. It's the same fraction, just with different numbers. And this fraction is going to stay the same because it's already got a matching denominator. And then I can add them together. Now 4x plus 6. I can't actually put these together to make 10x because this isn't 6x, it's just 6. So I have to write this. It's 4x plus 6. Just show that they are added together in one fraction. But of course this is all part of an equation, isn't it? So now I need to solve this. So let's rewrite it up here where we've got a bit of space. So 4x plus 6 equals 5 all over the 10. And what do we do? Well, first of all, we're going to times by 10. I hope you did that, because that will cancel out the divide by 10. But we're going to times both sides of the equation by 10, both sides of the equal sign. So this side is now 4x plus 6 equals 50. We'll then take away the 6 from both sides. That should be 6. Come on, computer, catch up. 6 take away 6 leaves nothing, so 4x is left on its own. And 50 take away 6 is 44. And I don't want to know what 4x's are. I only want to know what one of them is. So I divide it by that number touching x. Ah, that's why my computer's being a bit laggy. It's just told me it's low on power. So bear with me just whilst I plug it in. Just, talk amongst yourselves for a while. There we go. Right, then that's better. So we're going to divide by 4 on this side as well. 44 divided by 4 is 11. Okay, so that's what the value of x is. Let's try this one. Okay, so 3 won't go into 5, 5 won't go into 3, or at least it won't do it easily. So we're going to use the other method, aren't we? We're going to multiply together these bottom numbers to get 15, and that's my new denominator. Both the fractions will be over 15. And we need to times the y by 5 to get 5y. And we need to times this y by the 3 to get 3y. And that all equals 4. Okay, we can add together our fraction then. Again, let's do it up here where we've got a bit more space. 5y plus 3y. I can put those together because it's both amounts of y. So 8y all over 15 equals the 4. Okay, how do I get rid of my divide by 15? I times by 15 because that will cancel out. They cancel each other out to just leave 8y on its own. But I can't just make this side 15 times bigger. I must make this side 15 times bigger as well. Now 4 15s are, there's a rhyme for this, 4 15s are 60. And 8y equals 60. Now I don't want 8y, I just want one of them. So what do? I divide by the number touching x. I divide by the 8. How many 8s go into 60? I'm pretty sure I know what that is. It's, because 8 8s are 64. So it's 7.5. I could use the calculator, but I managed to do it in my head. So 7.5. Not always a whole number. True. You know, it sometimes happens. And what have we got next then? 2 more to do. Okay, so I'm really starting to push the envelope a little bit here. We're trying to work you hard. 2 more to do. Press pause on the video. Unpause when you're done. We have unpaused. Okay, so the second fraction is over 10. First one's over 5. So I can adjust this again to be over 10, can't I? I am going to times the top and the bottom by 2. So let's double this then. And let's preempt the fact I'm going to run out of space by writing it over here. So 2 times y is 2y. And 2 times 5 is 10. And the second fraction stays the same because it's already over 10. And that equals 5. Now I'm going to add my 2 fractions together because I can, because they've got the same denominators. 2y and 3y can be added to make 5y over 10 equals 5. I want to get rid of the fraction, so I times by the 10, and that cancels it out. But I've got to make this side 10 times bigger as well, not just the left-hand side, but this side too. 5y has been left on its own, and 5 times 10 is 50. I don't want 5y, I only want to know the value of 1, so I divide by that number touching y. So it's 10. Y equals 10. See, I'm going a bit faster now. Hope you got that. And the last one. Do I need to times these bottom numbers together? No, I don't, because look, the 2 will go into 6. Now, I could times them together. You know, you still get the same answer. It's just you have to then simplify later. Okay, so times by 3 on the bottom and times by 3 on top. Let's put a little separation line there. 3 lots of x is 3x, and 3 lots of 2 is 6, because that's what I wanted. And that's still 5x over 6, because that was already over 6. I can now add together my fractions because the denominators are the same. 3x and 5x will go together to make 8x over 6. And that still equals 4. Now I don't want it to be over 6, do I? I want to get rid of that, so I times by 6 because that will cancel it out. But I must times this side by 6 as well. Now 8x has been left on its own. 4 times 6 is 24. Okay, again, last time, I don't want 8x. I only want to know the value of one of them. So I divide everything by that number touching the x, by the 8. And there are 3 8s in 24. Woohoo! Right, there should be some My Maths tasks set for you to do, or other work. So off your toddle and go and do those. And good luck with what you're doing. If you need to watch the video again, maybe take it back and just see how I managed to do it. Okay, off you go.